Okay, so members, now we are going to see more examples about combinations, but please don't forget to subscribe to the channel. Now, this one we are going to see how do you handle at most cases, how do you handle at least cases in these examples. Now, to start with, we are starting with this first question. It says, a committee of 4 people is to be chosen at random from a set of 7 men and 3 women. So now, start by summarizing the question. We are going to form a committee of 4 people. So we need a committee of 4 people. We are choosing them from 7 men and 3 women. How many different groups can be chosen if there is at least 1 woman? Now here, the idea is very somehow different. Look at it. Part A, number of ways are going to be of how I can choose this thing. Now, if they say at least 1, at least means that number is the smallest. If they say at least 1, means that the smallest number on that committee should be 1 woman. Means that now you look at the women you have 3. Means that you can choose 1. You can choose 2 of them, or you can choose 3. Up to 3. Why am I ending at 3? Because they are only 3 women. If they are 5, you end at 4. But this one I'm ending at 3 because there are 3 women only. So, because I'm going to pick these ones, now that will be. Now I'm going to form a committee of 4. But so the number of people I have is 10. I need to form a committee of 4. Meaning, the women, if I start with the first 3 women, I'll be having out of the 3, I can choose, now at least 1, I can choose 1. Times, if I choose 1 woman, the balance of the committee is that I want a committee of 4 people, the balance is going to be 3. So those 3, I'm going to pick them from these men. Out of the 7, now I pick 3. Then plus, now I increase the women to 2. So out of the 3, I can take 2. Then times. Now out of the, because this one I have 2, I need 4 people. Meaning that if I have 2 already, I'm having the balance of 2. Meaning that in the 7, I'm going to pick out 2. Then plus. Still, I can choose 3 of them. So out of the 3 men, I choose 3. Then times. Out of the 7 men, now I'm going to pick, because the committee requires me to be having 4. So if these are 3, I have a balance of 1, so I'm going to pick them from the men. And the answer here you have is 175. You can now form 175 groups if every is having at least 1 woman. Then part B, they are telling us that at least a man, at least 1 man. So here the number of groups are going to be, number of groups, they are going to be, so I will need at least 1 man. Meaning, if I need at least 1 man, now I can pick 1, I can pick 2, I can pick 3, I can pick 4. Now the men are 7. So I can't go beyond the 4. Why? Because the committee is having 4 people. That's why I'm stopping at 4, even though the number of men are 7. But I'm stopping at 4 because the number of committee needs us to be having exactly 4 people. How am I going to choose? If I start with 1, out of the 7 men, I'm going to take 1. Then times the balance, I'll pick from 3 women. See, from 3 women, I'm going to take a 7 minutes with 3. I can choose now. I need 4 people, so I can choose 3. Then plus, out of the 7 men, I pick now 2. Then times, out of the 3, now I pick 2. When I add these ones, they give me the total number of people I want on the committee. Then plus, out of the 7 men, I can pick 3. Then times, out of the 3, I can pick now 1. Then plus, out of the 7 men, I can pick 4. Then times, now in the women, because I have already 4 people, it means that in the women, I'm going to choose 0 because the number is already there, which will give me, when you press that on the calculator, it's going to give you 2 10 groups. So that's the answer that I'm having. Now, so that's how you can handle that question with ease. That is the case. Now here we are coming. Here why I'm not choosing because the committee is already 4 people. I can't add on another because they didn't have 4 people. So from the women, if I pick 4 men, women I pick 0. How many different ways can a team of 8, 9 children be selected from 10 boys and 8 girls? So you summarize the question. So you want to pick a team of 9. You want to pick a team of 9 children, but you are picking them from 10 boys and 8 girls. Okay. If it can consist of either 5 boys and 4 girls or 4 boys and 5 girls. So the number of ways here I'm going to be having of ways. So that means that this team can consist of either 5 boys, so out of the 10 boys, I can choose 5, then times the balance that I need a team of 9. So if I have 5 already, the balance is going to come from girls, which I'm going to pick 4. When I pick 4, so when I add these ones, I get the total number of children I want in the team. Or can consist of 4 boys. So out of the 9, I pick 4, then times out of 8, I pick 5. And from there, you just press your calculator. The answer we have is 29,400 ways. So that's how you can choose that team. When I come to that one, they're telling me a choir of 6 people is to be chosen at random from 6 men. So I need a choir of 6 people from 6 men and 12 women. 12 women. How many different groups can be chosen if a choir should have part A at least 3 men? If they start listing, means now if I'm part of my part A, the solution for part A, at least 3 men, meaning we can pick 3. If they start at least, means 3 is the smallest, up to the total number of men can have. So I can choose 3, 4, 5, and 6. I can't take 6 because I have already 6 men there. So now here the number of ways are going to be out of the 6 men. I can pick now 3. So now if I pick 3 men, I'll be having the balance of 3 to make 6. So I'm going to pick them from the women. So I'll be having now 3 combination, now 3. If you add these ones, you get 6. Then plus, out of the 6 men, now I increase the men to 4 times. Now the balance are picked from, these are 4 and the balance of 2. Why am I doing this? Because at least means that's the smallest. You can pick from that number up to going up. So plus, now if I increase out of the 6, I can pick 5, then times out of the 12 women, I can pick now 1. I think you can see that. Out of this, I can pick 1. Then plus, out of the 6, I can take only 6 women. I can take only 6 men. If I need 6 sisters that I'm already having the number of people, mean that out of the 12 women, I'm going to pick 0. And then pressing that on the calculator, you have 6. So here I have 1,4,4,0,0, then plus, and I put that down. I have 4, 2, this is 9, 10, then plus this. I have that as getting a 1. And when you add all those ones, we have 4400, then plus 90, then plus 72, plus 1. So these are going to be 3 ways. Now, in part B, they want us to at most 3 men. Now, at most, whenever they say at most 3 men, it means that the biggest you can take are the 3 men. Meaning, I can take 3 now going downward. So I can take 3, I can take 2, I can take 1, or I can take 0 men. So that's how we have the 2. This one is at most. At most now means the biggest should be 3. So now the number of ways they are going to be, so I start with, out of the 6 men, I can take now 2. I can take now, 3. Then the balance, I'll take from the women. Combination 3. Then plus, out of the 6 now I take 2. Then times the balance is going to be from now the women, which are 12. I take now, because here I need a community of 6. Here I'll take 4 from the women. Then plus, out of the 6, I take now 1 man. Then the balance I'll take from the women. Then plus, out of the 6, I can take now 0. Then times, I'll take now I'll take from 12, I'll take 6. We have seen that this here will give us 4400. Then plus, if I'm to put those on 6, combination 2 and times. So this one is giving me 7, 4, 2, 5, then plus. This one is 4, 7, 5, 2, then plus. Add all those ones, we have 440 plus 7425 plus 4752 plus 924. That's what we have here. It's 17501 ways. So that's how we handle that case. Now, I'm going to pose a question here. If we had, say, look here, if we had 7 men there, if we had 7 men, and they are telling me at least 3, and these were 12 women, like that. Anyway, I will answer this in another video. Don't worry. I wish you the best.